Okay, good morning, everyone. My name is Eric Michaud. I am the technical manager at Corbec. Corbec is a hot dip galvanizing company. We do have 5 galvanizing plants across Canada, and I work at Corbec for 15 years now. I'm not the best English speaker of the company, but they keep asking me to do some presentation year after year, so I will do the best I can do. So, as with Mr. Phillips said with the Galvanized bridge in the presentation before, what we see in the hot dip galvanizing industry is that there is more and more demand for projects and infrastructure with sustainability and longevity greater than 100 years. Mr. Phillips said that the Galvanized bridge is designed for 130 years. So this is what we see in the last decade, that like in Montreal, the new Champlain Bridge have a design for 125 years. And hot dip galvanized steel is mainly used, it helps to get these objectives. So we believe that hot dip galvanizing is a key technology in infrastructure and sustainable development project. So here we have some examples. It could be used in reinforcement bars on steel as a building structure, or also as an architecture design, like the building we have here in Europe. There is more use of galvanized in Europe as in the design of buildings, the outside, and it is widely used. In North America, we see that galvanized is used inside the structure or for infrastructure like bridge or things like this, but in Europe it's used in the building itself. I have an example here. It's just what hot dip galvanized gives you is just the zinc layer over the zinc is 100 to 200 microns. It's very thin, but it could give you up to 100 years of protection. And it's quite easy to do. It's not expensive, and it applies to many shapes of steel. So today we will cover the origin of hot dip galvanizing. We'll see how it works, the advantages, and the use in infrastructures. And just for the test at the end of the day, I would like you to remember the atomic weight of zinc, 65.38. There's no test at the end of the day. Okay, the hot dip galvanizing take its origin 300 years ago with a French physician, Paul-Jacques Malouin, who demonstrate the method of coating ferrous metals by dipping them into liquid zinc. And it demonstrates that it protects the steel from the corrosion. So about 50 years later, Luigi Galvani, where the name galvanization came, is after this Italian physician who published his treatise on electric force. And what I have found since the presentation was in Toronto, I look at how Toronto looks at that time. So I found that in 1793, it was the establishment of the town of York. So a couple of years later, Michael Faraday, an English scientist, explained the principle of the cathodic protection. And it is one of the protection that zinc gives to the steel. 5 years later, the town of York became the city of Toronto. So we were far from all the buildings that we have now, 200 years later. And a few years after that, Mr. Stanislas Sorel, a French inventor, he patented a method for a galvanic method to protect. That was the beginning of the industrial use of what has been found before by Jacques Malouin. So it took merely 100 years, and then we will see now 200 years later, more than 4.9 millions of tons of steel are galvanized every year in North America. And there is more than 180 deep galvanizing plants spread in Canada and USA. And we think it's a lot, but in China, actually, there is more than 1,000 galvanizing plants. So how does it work? Basically, in a deep galvanizing plant, we do not produce the parts that we galvanize. We have some customers who are making the structure, weld the parts and all these things. They bring the structure in our facilities. And what we do before we dip the material in the zinc. Oh, okay, I have to change that. Yeah. There are some surface preparation because when steel comes in our plant, there is oil, there is dirt on the steel. So we have some big bath. The new plant we have built in Toronto, in Hamilton, is 17 meters long. So you could imagine this bath 17 meters. So there are degreasing steps, rinse, pickling in hydrochloric acid. This step is very important, is to remove all the rust that is on steel, because the zinc will not be, the steel will not be galvanized if there is rust on it. Then there is a rinse. And the last step before galvanizing is the flux solution that will activate the surface to prepare for to react with the zinc. And all this process is quite fast. Let's say the surface preparation is about 2 hours, and the time in the kettle we call the galvanizing bath a kettle, is about 5 to 10 minutes. So in 5 to 10 minutes, you could have 100 years of rust protection on steel. So what makes the deep galvanizing so efficient and resistant is that it's not just a coating like if we add paint on steel. There is a metallurgical bond between iron and zinc. So iron is diffusing into the zinc to form the zinc coating. And the interesting is that the intermetallic layers are harder than the iron and the zinc itself. So it makes it very abrasion resistant. So you can see on the picture the steel, the zinc coating, which is about 100 microns on this picture. So the main advantages is with deep galvanizing is a barrier protection. You dip the steel in the zinc. So even if you have a tube or a square box or something like that, so zinc will be outside and inside. So the protection is on all the surface. There is the cathodic protection. So if the part is cut or is scratched, thanks to Mr. Faraday, as we saw before, zinc will continue to protect the steel because it will sacrifice itself until there is zinc on the part, and it will protect the steel from the corrosion. And one of the interesting is the zinc patina. Zinc patina is over time when zinc is exposed to air, it will react with the carbonic gas that is in the air, and will form a zinc carbonate. And this zinc carbonate layer is impermeable. So the next corrosion, a contaminant or air or things, will not go through that thing. Like on bare steel, the corrosion products are permeable. So there is always new corrosion under the patina on steel. But with zinc, the patina gives a very good protection, And we can see, like it says below, it slows the corrosion rate to 1/30 of the rate of the steel in the exact same application. So this is why additive galvanizing is used everywhere. So I talked about the abrasion resistance. There is also a complete coverage over even on the edges, since the metallurgical growth goes in all the directions. Even on the sharp edge or things like this on the part, you will have the same thickness of zinc coating. And also, zinc is compared to paint or organic product, is not affected by UVs. The durability on this chart, you see, the chart is in mils, but we could see that 5 mils is 125 microns. And on the y-axis, we have the time for the first maintenance. And this time is defined, is not the time where the part is all rusted and has to be replaced. It's just the time when, as defined, as there is 5% of rust on the surface of the part. So this is what we call the time for the first maintenance. And on the Gaudiard project, we supply a lot of steel for that project. They have asked for 130 microns minimum on their part, and we can see if they wanted their bridge to last 130 years, if we go up on the axis, they need more zinc thickness. So zinc thickness is directly related to the longevity of the parts. On the life assessment a cycle of additive galvanizing, we see that most of the energy occur during the production of the steel, of the zinc, and the galvanizing process, which will emit carbon oxide and SO2. But then during the entire lifetime of the part, there is no input for the maintenance. So it's mainly used in bridges, light poles, parking garage, truck farms, sign structure, even now in solar power infrastructure, and windmills also. And in the loop, at the end of the end life of the product, you have to remember that zinc or steel or metals and all this industry, the recycling is very well integrated. So you can just melt the iron again and you can produce new product. Just some information about the modern additive galvanizing plant. Maybe some of you have some experience with galvanizing plant who are just galvanizing bath with a lot of smoke everywhere and rusty buildings and no scrubber. Most of modern plants now have kettle enclosure, dust collectors, acid scrubbers, stormwater treatment system. So we want to be a friendly industry and environment. And the product we have is this. So the facility must have these concept. Oh, yes. Because sometimes I change this, but this is what I was talking about. So this is the plant we have in Hamilton. What the picture in the middle is the pre-treatment area, and you have an overview of the plant with the enclosure on the far right. Now I will give you some example of use and reuse of zinc in the industry. This is an interesting case study. It's a bridge in Michigan built in 1955. In 2007, they had to repair the guardrails. So instead of producing new guardrails, using steel and zinc again. They said the guardrails are still in good shape. We just want to refurbish them with new zinc. So they remove the guardrails, they strip the zinc, they galvanize again, and reinstall the guardrails on the bridge. So by doing that, they have saved a lot of energy to making new projects, and they save a lot of cost on that project. I think this is, from what I have heard this morning from the people in the city, this is the kind of thing they like to do. They have to decide with infrastructure to last very long and are reusable. This is an example of it. There is an association of galvanizers in North America. It's called the AGA, and there is a lot of resources available for the developers. So there are some design document, design for bridge. This one, the third one is design detail for architectural exposed structural steel. So this building is all made with the galvanized exposed steel. And also, there is something we could find is some duplex system. If you said we need to have the protection of the galvanized steel, but we would like to have some colors, but there are some guides for paint and powder coating over galvanized steel. There is also, this industry is all the galvanized process is governed by some standards. I will not go through all these details, but the main important one is A123, is the specification for hot dip galvanizing. And there are some to provide high quality zinc coatings, how to repair and maintain, safeguarding against the distortion. And there are more over there, but sometimes we have a question, is hot dip galvanizing lead? As lead doesn't specify product, we cannot say that hot dip galvanizing is lead. But the way it works is that hot dip galvanizing can contribute in points in the evaluation of any lead project. So now I have just some example of infrastructure. A few years ago in Montreal, they have decided that the Champlain Bridge was only 65 years old, but because of the use of de-icing salt on the structure, it became very dangerous and the very high maintenance cost of that bridge. So they have decided to build a new bridge. So the bridge on the right side is the new one, and actually the old Champlain Bridge is almost removed from that. They took all the steel and they disassembled the bridge. So there is a lot of dip galvanized, and the specification for this bridge is 125 years. The design criteria from Hydro-Québec is 100 years, and for the transmission tower and all the electricity facility. These are some examples of duplex systems. This is an example in Calgary. They have chosen to specify hot dip galvanizing for the light rail transit system, and this is an example they have done a few years ago. This is an architectural example. The San Diego Central Library, they built a dome over the library just to have a great aspect. This one is interesting. There is a bridge in Stoneham in the north of Quebec. This bridge has used a lot of deep galvanizing products. Since for the concept of that bridge, it is in a seismic area, but it has to be very strong. So for the arch, they have decided to use bendable rebars. So all the arch, oh, I have to move. All the arch is reinforced with bendable rebars. The structure of the deck is made from H-beam galvanized, and the deck itself is in concrete with rebars, with galvanized rebar reinforcement. There is an example of a multi-purpose overpass in Sainte-Marie-de-Beauce. So the Calypso Park, maybe some of you know this park close to Ottawa. All the structure is galvanized. Every time I go with my children, I look at the galvanized and how it resists to this. There is, in that project, there is a company that can rent some modular parking. So if there is some event or things they need a parking for 6 months, they can arrive with the galvanized parking. 2 more slides. I have some, when I walk in some cities, I always take some picture of good and bad things. So there is a guard at the entrance of the McDonald's. It's just paint over steel, so you can see the rust. And the picture on the right is an interesting one. There is, it's in the old port of Montreal. The stairs are galvanized, but the rails are just painted. And you can see over years, maybe this is there for more than 50 years, but you can see how the painted parts are rusted, but the stairs are still in good shape. And the 2 more examples. Last week I was in Connecticut, and there was a pedestrian bridge using galvanized. And this one is a fancy bicycle rack, and I saw in Quebec City, which is, there is wood and galvanized product together. So a quick summary, the advantage of update galvanizing is longevity and durability, sustainable option for corrosion protection, high abrasion resistance, low carbon footprint, long-term maintenance free. So the long-term corrosion is important, maintenance free is important because when we have a project this year, we don't want to have the high maintenance 30 years later with the cost of maintenance that will increase at that time. So with galvanized zinc is with galvanized product, the maintenance costs are very low. And that's it. Thank you.